You then have your statement, you need the list of what you know, and what you're finding. I would say at the very least, we need to make a what you know. What you're finding, there's gonna be apparently a part A, a part B, and a part C. We won't problem. But I didn't know, I just have to make a list of what we're finding. Oh, no. Give you guys about a minute for the call. Yeah, what's one thing that I know? What's one piece of data that I can share? Okay, in 1970, year 1970, the house is worth, you know. So that's why I made a piece of the house.
In 1980 was 80,000.
Okay, 1980, prices, 80,000. Cool.
And
X represents years.
What was that?
X represents years.
Okay, X represents years.
in 1990, the house's value was $200,000.
Yeah, Karina. And specifically, for X, it says property, number of years property was owned. I feel like we need to define this variable a little bit more. What should I maybe?
Oh. Years after.
Yes. Number of years property has been owned after 1970. You're like, whoa. That does not say that anywhere on it. And you're right, it does not say that anywhere on it. But why is that a very smart play? Okay.
Because when we're setting up, you want to set the farthest back one.
Yeah, it's a good idea to make whatever your earliest data point is, set that to 0, call that 0. Because now when we're graphing this, imagine if you're trying to graph this, you really want to draw all the way up to 1970, you want to draw 1,970 lines? No. Do you want to do these by decade? Probably not. Let's just make it easier for ourselves. Call this 0. What about Y? What's Y going to be?
The price.
Price, right? So I'll say like price. But I think we should also do ourselves a solid here. Price in maybe in 10,000.
Maybe.
Why are we choosing an increment here? We don't have to, I mean, we could say that this first coordinate, if we didn't say 10,000, we'll just say dollars. What would we call this as a coordinate then?
0.
It would be 50,000. You really want to have a Y coordinate of 50,000? No, I think I'd rather go 50. 50 is so bad. right? You see what I'm saying? So chop off those extra zeros. Why do we need them if we don't, right? So with that being said, what's gonna be the next quote? What's the next one gonna be?
And
No,
comma 80.
1080. Why is it 10?
Because 1970 equals 0.
10 more, 80 is 10 more years, right? And then,
That's 200.
and actually, you guys, I should write 10,000. Let's go by just thousand. Sorry, I don't know. We could have went 5 and 8, whatever. Sorry, I'm gonna change this. I'm gonna go to thousand. Sorry. I could, like I said, go 10,000 and call that 5 and call that 8 and call that 20. You could do that. I'm just gonna go thousands. Okay, so 50,000, 80,000, right? What's this last coordinate gonna be then?
10, 20.
20,
To
100,000, right? 200, yeah, 200,000, right? That's why I like the idea of thousands, okay? You could say 10,000, but if you do 10,000, you're really missing that extra. I like being able to just go, okay, 50,000, 80,000, 200,000, like that just feels easier to me. But again, you can do it either way, okay? You could have just decided to call Y money, and you wouldn't even have to say, like, you could just write 50,000 here, 80,000 here. But doing that math is gonna be gross, I tell you that. Because already, what can you tell? What is this? It's gonna be a quadratic. Well, why? We're in chapter 7, and chapter 7 is about quadratics, but also, these are 3 points. What's the bare minimum amount of points you need for a quadratic? 3, right? This is already kind of leading me into thinking that I'm probably gonna have to use quadratics. This is probably gonna be a system of equations, possibly, with 3 variables, or possibly, right? Okay, so let's keep moving on. So what am I finding? Oh wait, some other things I might want to know. Hold on, forgot. They tell you that E of X is the same as Y. Right, they tell you that. And they actually tell you it's a quadratic function. Listed clear as day right there, right? So you know this thing is quadratic. And does anyone recall what standard form of a quadratic looks like? Yeah. Let's see, equals, oh, what?
Oh, yeah,
Y, traditional, equals Y. We're used to seeing it kind of equal to 0, because we're saying that that's where we're trying to find X, right? But normally it's just equals Y, okay? Or in this case, V of X, okay? What they need you to do, it's actually all loaded in this last sentence. Find the value function f of x. Okay, so in other words, that's code for create function for of v of x, right? That's the good part. All right, part B. Well, actually, so what is that code for? When we say create function value of f of x, what is that technically just saying? How about create a quadratic equation? Right, that's what that means. Create an equation, guys. Specifically, create a quadratic equation. Part B, keep reading what it says here. Find the value function f of x. Determine the value on January 1st, 1996. So I need to apparently find value in 1996. So what am I technically finding? An X or a Y? A Y, because Y is value, right? So this is, when we say find value, that's technically Y, right? How will I find that value specifically? Plug what in for X? Plug in 26 for X into equation. So part A is asking you to create the equation. Part B is basically needing you to use that equation. Why 26? 1996 is 26 years after 1970, right? Okay, cool. Last thing though, we're still not done. There's still an and there. And find when the house will be valued $1 million. So part C is going to be, when will house be worth 1 million? What am I technically finding? When I see the word when, what does when indicate? Time, which is X, right? So key thing I'm finding here, this, when we say find value, the value is Y, this is X. So apparently we're going to find the X when the house will be 1 million. So how will I do that hypothetically?
Using the equation in part A.
Yeah, and what will I do with that equation? Plug, so plug what, where? Plug in 1,000 for Y. So in theory, we could say, set equation equal to 1,000. And if you're like, why 1,000? Because 1 million in thousands would be written like that. Oh. Let me tell you about the Mayan number system someday, and you'll be really appreciative. It's base 20. And if you're like, what does that mean? Just to sum it up, basically we're base 10. Basically, I don't know if I really want to go down this rabbit hole, but we refresh at 10. So once we hit 10, numbers are no longer considered ones, right? Like if you think about it, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then as soon as you get to 9, you're no longer in that last column. You now move to the 10s, right? For them, they don't refresh until 20. So the number 12 is still considered a 1. 13 is still a 1, 14 is still a 1, 15 is still a 1, 16, all the way up to 19. Then once they hit 20, their next place value is going to be 20s. Our place value after our 10s is hundreds, right? Theirs is going to be 400. Theirs is 400. And you're like, whoa, what, why? Well, ours is probably base 10, probably because we have 10 fingers. Truth be told, historically, like that's probably why. Why did they maybe go 20? Maybe feet and toes. Yeah, possibly. Okay, so there's your ethnic math study for today. Okay, see guys, we've got everything laid out. Now we just got to do the first step. We got to create an equation. Does anyone have any bright ideas?
I would say
Okay, I'm going to give you a hint. Substitution is your friend
Oh.
until the very end. So let's do part A. You were told that you have to create a quadratic equation. Isn't this the template for a quadratic equation?
Yes.
The answer is yes, right? We have 3 points to roll with. So let's write those 3 points down that were graciously given. And let's start doing some substitution. You know that a quadratic looks like this. So let's work with the first points. What can I now write for this first equation, basically? Using substitution. Not x, a
squared.
Thank you, Shivneil. A0 squared plus, what's the next part? B times 0. Then what's next? I mean, it's kind of lined up, guys. Plus C, because I don't know what C is, right? I don't know what C is, equals 50. Boom. There it is. Okay. Before we move on and do this rinse, slather, repeat thing, just slather, rinse, repeat thing, let's simplify this further before we go through the same exact process with the next point. So what are some things I can do? Well, 0 squared is just 0 times A. Doesn't that make that whole thing disappear? Yes. Second term, B times 0. 0, that goes away. So I actually end up finding out what C is. C is 50. But here's the thing, you guys, we should have already been able to know that. For what reason?
0, comma 50.
Y-intercept always occurs when X is 0. Think about again, coordinate plane, right? If you have a coordinate plane, the only way you're getting a point on the y-axis is if X is 0, because if X is 1, then you're gonna have some point over here. If X is -1, you're gonna have some point over here, right? The only way to get a point on the y-axis is to have an X is 0. And based on our video, when we first started this unit, we were told that C represents the y-intercept, right? So we could have already put 2 and 2 together, but it's fine, we see it now. As long as we see that at some point, we're good. Okay, so we know that C equals 50. I know, good pun, right? So what's my next equation then? A times 10 squared. Next, what's next? Maybe I'll draw a little line here to kind of separate it. Plus B times 10 plus 50, because we know what C is now.
A and B always equal X.
No, A and B do not equal the X coordinate. I mean, they're always connected. A is always connected to X squared, B is always connected to X. It always takes this form for a quadratic, Okay, what does it all equal? 80. Let's simplify this one before we move on to the last one. So what's my first term going to turn into? 100A. Not A squared, 100A. Because the only thing that's being squared is the X, right? If the A was also being squared, there'd have to be parentheses around both. There isn't. So when you see something like this is communicating only the X is being squared. So we have 100A. What do we have after that? Next term. 10B plus 50 equals 80. Ta-da, that is as simplified as we can go, right? We can't combine any more terms. This is an A term, this is a B term, this is just number. I mean, I guess we could move over that 50. Do you guys want to?
Yeah.
Okay, sure, let's do it. So let's subtract 50 from both sides. Let's really get this simplified, right? So now it's going to be 100A plus 10B equals 30. Do the last one by yourself. Take your time. What's up?
Should we technically divide 10?
If you want.
Yeah.
I'm not going to though, not yet, not till I see what's going on with the next one. And if you do that, part of that's just a personal preference, if you just want them to have smaller numbers, but it's not necessary. Okay, so do the next one, please. All the way from start to finish, try. Because again, when push comes to shove, you have to be able to do this by yourself. So you might as well try. Okay. Get this as simplified down as you can. Hopefully, you guys have 400A plus 20B equals 150. Let's think about what are we even doing again? Like the big picture here, what's part A even doing? Finding an equation, right? At this point, what's something that we've already done towards that step?
Found C.
We already found C. Cool. So like right now, I know this equation is going to have a C of 50 right here, right? What do I still need to do? I still need to find A and I still need to find B because it's a system of equations. Do it.
Yeah.
Find A, find B. Once you find A and once you find B, plug in the number for A here, plug in the number for B here, plug in the C that we already found, ta-da, you have your equation. Right? I know, we're gonna this all works. By the way, this process that we just did, 7.2, 7.2 for your book assignment is this. So you could work on 7.2 tonight. This is not scheduled. I will do my work quietly to myself over here. You have to make a decision to get rid of A or B. I'm rolling with B, let's see what it's going. Okay. So here's my work. You either, and I know it might be a little hard to see, guys. It's either exact number 90/20 or 0.45. Now that you have that, try B, yes. You decide how you want to do it. You can either plug A into this equation or A into this equation to solve for B. I think I'm just going to go with the first one. I think I'm going to just write it as a decimal, because why not? It's not a bad decimal.
Yes. I can't even do that.
Okay, so cool. I've got B, hopefully you got -3/2 or -1.5. Note that I still have not done what I need to do. What's the final thing I gotta do? Write my equation, right? Write my equation. So now I just have to substitute everything in. So ax squared plus bx plus c equals y, or I guess I should really say b of x, because they told us to do b of x. Right? So that this is going to officially be. And again, you decide how you want to write it. You can write it as fractions, you can write it as decimals. I would say it's okay to write it as a decimal as long as it is a clean decimal. A terminating decimal is what we like to call it, where it actually ends somewhere. If you can see that it continues on and it's pretty long, I highly recommend you use the exact number, which means change this to a fraction. So in this case, I'm totally fine with 0.45 x squared minus 1.5x plus 50 equals b of x. Okay, but again, like fraction, I don't care. Okay, the only time I care is again, if those decimals are not terminating, if they aren't terminating and they're really, really long, I prefer to write it as fraction. Okay, so here's all my work for part A. From beginning to end, I realized that, see, there it is. Okay, if you're feeling confident, go part B. We already laid the groundwork for what you have to do. You've got your equation. Use it. I guess you move on to the next page. Okay. So something I want to remind you, the question that was asked of us was, determine the value on January 1st, 1996. If you say $315.20, and I go, wow, can I buy that house?
Yeah.
Okay, you have to go back to think to context, right? So what's my actual answer? Is that house really in 1996 only selling for $315?
Definitely, that's a cheap
Definitely
house.
not, like I would hope not, right? So what's this actually gonna be? 315,000, because remember, we decided to make Y's thousands, right? 350,200
Oh.
in 1996. You have to always go back and ask yourself if your answer feels reasonable to the question, right? And the question's asking the home value. You are not finding any house, not even a door for $315, right? Like that doesn't feel plausible. So then you have to ask yourself, wait, did I mess up on the map? Or do I need to think back to the context of the problem? I already said Y is in thousands. So if I said Y is in thousands, if I have 315 of them, 315,000. Yes, sir.
Sorry. I mean, a little bit. For the next one,
Right.
we use the quadratic form.
Yes.
Oh.
So if you go back and you look, right, what is part C asking again? We wrote it down. Part C says, when will house be worth 1 million? And we talked about how we have to set the equation equal to 1,000, right? So that's easy. Like we set the equation that we already found equal to 1,000, right? That's what we have to do. And the goal is to find X. It was really easy when we had to find Y, because all we had to do was just plug in the X's, do the math, and there it is. But the problem here is our X's, we have an X squared and we have an X. So that's code for, this is a quadratic, right? We're trying to find X. We've got to use quadratic formula. So I'm going to subtract 1,000 from both sides. Yes, this feels odd. Yes, this feels strange. Why are we subtracting 1,000? Why are we not moving over the 50? Because to use the quadratic formula, you need the equation set equal to 0, right? So this is going to turn into 0.45x squared minus 1.5x minus 150. Here's your A, we already did that. Here's your B, here's your new C. Use the quadratic formula. I would like you to try this on your own. If you don't recall the quadratic formula, you really probably should have it written down somewhere because before you didn't know about quadratics. Okay? Negative B plus or minus square root. All right. But this will probably be the last time. Make sure you go all over to it. The whole thing is over to it. So do the math on your own, guys. I'm going to do it. You can look up at any point if you want to just confirm you're doing it right. Okay. I would not normally do every single step the way I'm doing it right now, but I'm just wanting to remind you that like when you do this, you really should probably multiply the 40C, have that done done. You really should square the B. Combine that. I mean, I normally would probably not do that. I'd probably write this and just calculate that. But whatever.
Only 1926 is not a year.
You're done. You're done.
1926. Because look, it's a parabola. Look there, when the value goes up and then down. So back in time, 1926. Coming back in 2017. If we graph it, is that not a point? Come on. No.
Yeah, it's time to be negative. Okay, so here's our two answers, and usually when we do the quadratic formula, usually we will get two answers, right? The only time we get one answer is when the inside the square root, we call that number the discriminant. If that's ever 0, that will result in only one solution. That doesn't happen often, but it can happen. And then there is the possibility of no solution. Does anyone remember what happens? No.
There are no.
The discriminant is a number that doesn't exist, a negative number in the square root.
You can't square root.
You can't square root a negative, or we can using I, but what I'm saying is it creates a non-real solution, right? So that's why more often than not, you guys, we do have two solutions, because generally we can take the square root of a number, right? The only time we won't have two solutions is if for some reason there's 0 in here, which means there'll only be one solution, or there will be no solutions when that inside that square root is negative. When I'm looking at this, again, relating to what am I even doing again in this problem? I'm trying to find out when is the value a million. When? Well, it's either 47 years later or negative 44 years later.
Oh.
That does not make sense in the context of time, right? So we're going to make a little note. Doesn't make sense in context. Right, doesn't make sense in context. I don't know that you need to write that down, but I'm saying time, really, we don't care about, you know, time important. So this is it. So at what year? 47 years after. Okay, so you can do it this way. You can either write 47.6 years after 1970. That's one way you can write your answer, or what's the other way you can write it? 2017.
Okay, Miss Shivneil.
Right? Because that is 47 years later, 47.6. I mean, if you really want to be specific, you can figure out what the 0.6 is. You could use unit conversions. Right?
No, it's not.
Oh
my gosh.
Is
I'm
that,
recording that. That was cut in 4K.
Oh my God. Okay.
isn't that June?
So you guys, let's do 7.4.1. Go on a brand new page, 17.4.1. I'll leave this up for another like 30 seconds before I move on to the next page. So 7.4.1, make sure to include the picture.
It's gotta be more.
Make sure to include the picture. There is a picture of somebody kicking a ball. Make sure that picture goes with it, okay?
That's a big four.
That's a 10 out of 12. There's 12 months.
Oh. Oh, wait.
You do 0.6 at 356.
We need July.
Hang it up.
Okay, so this is the problem that we're doing next. Again, make sure to include the person kicking the ball. I do not believe we're gonna get to 7.4.2 today, but that is okay. We can get to it on Friday. Okay. I want you to note that traditionally, I do not actually do both assignments 7.10 and 7.12 with the class. So if we get to it on Friday, cool. If we don't, it doesn't matter. I might just record something online and post it up, but it's never been something I have to do. Okay. What I have to get through is 7.4.1 and 7.4.2 by the end of Friday, which we're going to be fine. Okay. So please read through the problem once you have it in here. Make a list of what you know, make a list of what you're finding. These lists are really helpful. Yes, they take a little bit of time to create, but they're really helpful. You can quickly just refer back to them instead of referring back to the problem. They'll still help. Real quick, before we move on, it's 7.4.1. I want to talk about something. We want to talk about 7.4.4 again. There was something that I forgot to mention. So this is a pretty classic example of a problem that you face on your next assessment or the book assignment. Okay, but I want to tell you that this is not considered a higher level quadratic problem. And I'm wondering if any of you guys know why. I'm going to slide it down this way.
Get the.
You were given the y-intercept. As soon as you were given the y-intercept, that made your life a lot easier, because if you think back over here, right, when we started to do this process, you're 50, 200, we know the process, right? Plug in this value for x, plug in that value for y, and you have to go through this process for all 3 points, right? We were fortunate that our first point was the y-intercept, because what was nice about that was we were just told C. And from here, we were able to use that information into the other 2 points of the equation. Do you guys agree? What happens if you're not given the y-intercept?
You have to take a variable to eliminate.
It's going to be a system of not 2 variables. It'll be a system of 3. Okay, so we looked out on this one. You were given the y-intercept on a silver platter, which essentially eliminated a variable for you. You did not have to find C. You were given C, right? I'm here to tell you, you will not always be so fortunate. Okay, so sometimes your 3 points maybe won't include a y-intercept. And when that happens, that means you're going to have an A term, a B term, and a C term for 3 different equations, which is a system of equations with 3 variables.
We like find the slope going and find the line.
What slope?
It's
Quadratic isn't linear. It's not a line, right? A line has a slope. A quadratic, does a quadratic have a slope?
No.
Does it have a consistent rate of change? Not by a singular number, no. It does have its own pattern, it's a quadratic, it has its own pattern. But it's not linear, so no, you have to go through the process of solving a system of equations with 3 variables, which is a skill we talked about today, okay? So I think it will pop up at some point, I just wanna let you know, if that's the worst case scenario, is you're given 3 points, one of them ain't 0 something, okay? That's what I'm saying, if you can't solve a system of equations with 3 variables, you need to get to that point, because it's gonna pop up, okay? So let's go back to this problem. What are some things we know?
You know that the person starts at 50 feet off of the ground.
Okay, we know that the person starts 50 feet off the ground. So what does that really code for?
How high the person is.
Yep, we have, well, and we also know it's a y-intercept, isn't it? Starts, the person starts, remember y-intercept is where we start, right? Y-intercept is 50 feet, which is also the cliff height.
Oh, what do you work?
So the other thing that we know, I'm surprised no one just, we were given the equation. That's helpful, right? So I'm gonna write y of t. They did say s equals y of, I'm just gonna go with y of t equals negative 16t squared plus 48t plus 50. That's helpful. That's something I don't have to find, right? That's really helpful. I know some variables, they've defined some variables for me. T represents, yeah, so this is seconds,
After.
kicking the ball. So if we're thinking about this, T, right, is going to represent time in seconds. And that's going to technically be what we know to be the x-axis, right? So time is going to be down here. This is like 1 second, 2 seconds, 3 seconds, blah, 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 whatever, right? Seconds, okay? And so if I wanted to in this graph, I could go ahead and write a T right here, if I wanted to, right? And if I wanted to make this look more like a coordinate, what would this axis be? Y of t. Right, we kind of already said y of t, so keep sticking with the same variable, which represents height. Again, I could label this, right? Height in feet, right? And this was time in seconds. We might want to note that when we eat with the picture, maybe not. I didn't do it, but do it. I know it looks crazy, so I'm gonna do that now. Film, time in seconds, right? Anything else? We know it's a quadratic. Kind of feel like that's it, guys. Oh, we do know some other thing. We do know it's a quadratic, right? And we're gonna relate this back to graphical analysis. That big question Darren had was, why did we do the game one? What else do we know about this function just looking at it? It's a negative function. It's quadratic, and we can specifically say function is negative. There are 2 ways we know this. What are the 2 ways we can tell that the function is negative? The end behavior, right? The end behavior upside down. But there's also one other way we know this function is negative. We can look at our equation,
All the negative.
and then there's a negative in front. If you guys remember, all 3 forms, doesn't matter if it's vertex form, standard form, factored form. If there is a negative in the front, it means flip that thing upside down, and the function's negative, right? So we can actually tell by looking at that. And we can somewhere see in the equation the y-intercept 50. We can see it right there. Because remember, what, by the way, what form is this? Standard form. And standard form always gives you the y-intercept. And it also tells you if there's a vertical dilation, and it also tells you if the function's positive or negative. If it's negative, right? Okay, so now what am I finding? What is the maximum height of the ball? Okay, so part A, max height. Apparently I need to find what is the max height of ball. What is that also known as in mathematical context? Looking at this picture. It is the vertex. think about this, it's a parabola, right? It happens to be one of those ones that's upside down. What's the maximum height? Well, it's gonna be the very, very top point. What's the very, very top point? If it's flipped upside down. Yeah, it's the vertex. And specifically, say it, Quadros, I think you're the revival, it's what of the vertex? Uh-oh.
Yeah.
Maybe we're not about to be in my front. No, it's not the X, because what does X represent?
No, it's the,
Time.
it's the
It's
Y.
the Y.
That's what I meant.
But that's not what you said.
That's what I.
It is the Y coordinate of vertex. Because it always, you guys, always goes back to, you have to ask yourself, what is the X and what is the Y? In this scenario, X is time. What is Y? The height. If I'm trying to find the max height, I'm talking Y, okay? And just, I guess it's like a little foreshadowing, spoiler alert, X tends to be time, Y tends to be height or profit or whatever. That's how it tends to shape, okay? Why does it tend to shape that way every single time in most scenarios? Yeah.
Because Y is
Some sort of value, yeah.
And then time is moving that way.
And there's even more, there's another reason, but that's great, that's a visual representation of why it always makes sense it's gonna be like that.
The why.
That's exactly it. Money tends to depend on time. Height tends to depend on time. These things that happen and change tend to depend on time. And X is always the independent variable and Y is always the dependent variable. You're like sitting there going, all these concepts that I learned in 3-4, they actually, I guess, did serve a purpose. It gets weird to kind of just go, huh. Or maybe some of us are like, no, I cheated my way through algebra 2. So I have no idea what you're talking about. But for some of us, we're like, oh yeah, that kind of makes
I
sense.
took algebra 3, 4, 5.
Okay, so you're an expert.
Yeah.
Cool. I've taken algebra 2, think now for like 5 years. How many years have I taught algebra 2? I don't know, so, okay. Nonetheless, let's go part B. I'm digressing.
Please.
So part B. Part B. So we got the, what is the maximum height of the ball? When is the height? When is this height achieved? That's actually the next part. When
Oh, so it's just X.
is the max height achieved? So that is technically code for, yep, so when we say when, that indicates time, right? So we'll say T, or you could say or X of vertex. So really, we just need to find the vertex, right? If we can find the vertex, we will answer part A and part B. Okay, but we're still not done. There's more things. What is the maximum height of the ball and when is the height achieved? Next part, when does the ball hit the ground? So that's part C. When does ball hit ground? For my smart asymptotes out there, you're going right there. That's when. And you're not wrong, but you're not really right all the way. What is that in mathematical context? The root or the solution or the, right? But more specifically, I'm going to say the positive x-intercept. Or I could also say AKA when y equals 0. Don't you guys agree looking at that? One thing I know about that coordinate, that y coordinate 0, right? I gotta find that. How do we find that? Yeah, you plug in 0, right? You plug in 0 into the equation that was handed to you. Find x. How do you do that? Quadratic formula, right? Part D, let's talk about it. Part D, how high is the cliff? We actually heard you were doing that. You're sure you know what that answer is. What is that math context lingo for? How high is the cliff? What is that technically in math context? The y-intercept. Okay. So I don't do this too often. Or I give you a specific homework assignment. I want you to actually try to do parts A, B, C, and D by yourself, or your study group, or whatever. I want you to actually try and see if you can do it, okay? I will post up the solution online. Okay, I'll post it up. But I just want to see, can you walk through it? By the way, for those who are like, I have no idea where to start with part A, somebody help them out. Let's just talk about what would you do. If you're trying to find, we know part A and part B, you gotta find the vertex. How do you find the vertex?
Vertex onto the axis of symmetry.
Why don't you use the axis of symmetry? Does anyone remember what that equation is? Negative b over 2a. Don't you have the equation right here?
Yes.
What is that negative b over 2a gonna give you? Like, generally speaking, what is it going to produce? The x coordinate of the vertex. So in theory, you have then found part B, right? And then how do you find part A? Plug in that x in here, t, right, in here. That'll vary y. You will have found part A.
I think it's good enough.
And they'll be fully diagonal.
My phone right now is.
Oh no, somebody take a picture of it and post it.
I thought it was-
My camera is recording too. Man, you have, and I deleted my
Yeah.
phone.
Where's storing your icon storage?
Yeah.
Storage.
Yeah, I really want, that's right. I kind of set it apart.
How many pictures do you have? Like 1,000 something?
Yeah, Debbie? Yeah.
I have a lot of screenshots.
I was. Wow.
There.
Really?
Yeah.
I tried to
That was-
make it. See, guys, your homework is to try to do